We talk constantly about AI evolving, writing scripts, creating stunning visual art, but honestly, that's just scratching the surface.
Yeah.
We're now confronting a much deeper, um, more challenging integration. Truly autonomous systems,
Yeah.
AI that doesn't just advise, but could actually own assets, participate in corporate management, maybe even face legal prosecution.
And that's where we hit a wall.
Exactly.
Right.
We're running up against a legal system designed entirely for humans, social constructs, flesh and blood decision makers.
Right. And what's really fascinating here, what the research is showing, is this realization that trying to fit these incredibly sophisticated technical things into, well, human legal clothes,
Yeah.
it just doesn't work.
It's like trying to fit a square peg in a round hole.
Precisely. The sources we looked at are pretty definitive.
Yeah.
If AI is going to operate at scale, at speed, within our financial or corporate worlds, it simply cannot operate under human law alone. It needs its own rulebook.
An internal one.
Yes, defined by its own technical and operational limits.
Yeah.
Okay, and that leads us right into the core concepts for this deep dive. The absolute necessity, it seems, of creating what's being called a dedicated operational context, or DOC, for these autonomous systems.
That's the key idea.
So that's our mission today. We're going to unpack the research arguing that, look, standard human laws are failing these machines, and we'll explore some, frankly, surprising proposals.
Drawing inspiration from unexpected places.
Yeah, like autonomous vehicles, even the structure of international contracts, believe it or not, all looking at how we can define these operational boundaries for the next wave of AI governance systems. We're basically trying to figure out how to write the AI rulebook from scratch.
It's a big task.
So the moment we start talking about an AI system, say, owning part of a company or managing funds or signing a contract, we immediately bump into this idea of giving it some kind of legal personhood.
Right, and it's not theoretical anymore. It's actually being proposed as a necessary foundation just to allow the AI to function operationally.
But what does that mean, like actual personhood?
Well, this is a really critical distinction for you to grasp. This proposed legal personhood,
Yeah.
it isn't based on consciousness or sentience or feelings or anything like that.
Okay.
It's entirely functional. It's grounded in something called the theory of guarantee and the legal concepts of negligence and abuse in programming.
Guarantee theory.
Basically, the fundamental legal question is, if an autonomous system messes up, causes harm, who or what takes responsibility?
Okay. And that's where the tension really ramps up, isn't it?
Absolutely.
If we grant this personhood to the AI, does the responsibility lie with the AI itself? Like, does it pay a fine from its own digital wallet?
Yeah.
Or is this whole framework just a legal mechanism to guarantee that someone, the owner, the programmer, the manufacturer, will ultimately cover the damage? What does this guarantee actually guarantee?
Yeah, that's the core question.
Yeah.
It guarantees a point of legal recourse.
Yeah.
For now, let's be clear, it largely guarantees the producer or the owner ends up footing the bill. But by granting the AI system this functional personhood, we start treating it as an independent legal actor, at least on paper.
Why bother then?
Because if the AI system is truly autonomous, the theory of guarantee ensures that liability can't just vanish into the algorithm's black box. It forces us legally to define the boundaries. Where does the programmer's responsibility end, and where does the machine's independent function begin?
Okay, I see. And that gets us right to this fundamental divide that Hoffman-Ream highlighted back in 2020. Human decisions. They're fundamentally social constructs.
Involving empathy, context, often flawed or subjective intent.
Right, but algorithmic decisions. They're purely technical constructs, defined by data, by code.
Exactly. And trying to judge one, the technical construct, by the often subjective legal standards we use for the other, the social one, it creates these impossible binds.
The machine doesn't care about societal norms. It cares about optimizing within its given parameters.
Precisely, which, funnily enough, takes us back to that fascinating historical footnote you mentioned earlier.
Leibniz.
Yeah, the philosophical goal, dating way back to thinkers like Leibniz. Apparently, he dreamt of entirely excluding humans from the often maddening spiral of legal reasoning. Livermore mentioned this in 2020.
It's almost ironic, isn't it? Leibniz wanted predictability, objective rule following. And now we have the machine, maybe the only entity that, if you give it a narrow enough, defined enough operational context, can follow the rules without the messy spiral of human empathy or, political motives getting in the way.
That's the core appeal, right? Treating it as the technical construct operating under its own technical rule book.
Makes sense.
Exactly. But before we can really write that rulebook for corporate AI, we kind of need a successful precedent.
Somewhere this has worked before.
Well, luckily, we don't have to start completely from scratch. We can look at an industry that already built this precise kind of rule-following sandbox, autonomous vehicles.
Right. Self-driving cars. If you want to see a blueprint for defining machine boundaries in the real world, that's where you look. They use a standardized concept called the Operational Design Domain, ODD.
ODD, yeah. The ODD is essentially the machine's legal and technical envelope. The Society of Automotive Engineers, SAE, they defined it back in 2016.
Okay.
They called it the combined working conditions for which a given driving automation system is specifically designed to operate.
So it nails down the specifics.
Absolutely. It defines that technical envelope. Acceptable weather conditions, what kind of roads it can handle, maximum speeds, visibility, even time of day, and so on.
And the reason this blueprint is so critical is, well, safety and reliability, right?
Exactly. As Han pointed out in 2022, you must know the operational context to guarantee performance and safety.
That safety level is only guaranteed within this clearly defined, verified area.
That's the crucial part. If the car leaves the ODD, let's say it suddenly encounters 3 feet of snow when its ODD is basically sunny California.
Which happens.
Right. Then the safety guarantee is null and void. It's not designed for that.
So defining the ODD is step one.
Absolutely. The British Standards Institution, BSI, back in 2020, viewed defining the ODD as the non-negotiable first step in establishing what automated vehicles can actually do.
You can't tell the public what it can or can't safely handle until you've literally drawn the box it operates in.
So we've successfully applied this boundary mechanism to physical objects moving through the physical world.
Okay.
Now, the challenge is adapting that concept from roads and weather to corporate bylaws and regulatory bodies.
Okay, so we transfer the concept from the physical domain to the abstract. The dedicated operational context, the DOC, is the ODD equivalent, but tailored for an autonomous corporate governance system.
That's the idea.
But instead of focusing on physical stuff like rain or pavement or traffic signals, the AI is dealing with legal abstractions. That feels exponentially harder.
Oh, it is, no question. An algorithm can perfectly map every pothole on a street or register every single traffic sign. That's the ODD world. Tangible data. But how does it map something like reasonable conduct? Or interpret a vaguely worded antitrust statute? Or define fiduciary duty? That's the DOC challenge.
So what are the critical components then for this corporate DOC?
It becomes the legal and regulatory environment itself, and crucially, the interpretation and application of those rules by other AI systems, and importantly, by humans.
Wow.
The complexity just scales dramatically because the rules themselves are often shifting targets defined in natural language full of ambiguity.
So why are we defining this DOC? What's the goal?
Primarily, it's to ensure the AI keeps 3 core promises: that it remains lawful, ethical, and consistently reliable.
Okay, lawful, ethical, reliable. But getting those messy human laws into crisp, predictable code, that requires something called computational law, right?
Right. Computational law is that process of translating natural language laws, which, remember, are often deliberately ambiguous or rely heavily on human judgment, into executable formal code. And Messon noted in 2023 that this translation process inherently requires, well, compromises.
Okay, hold on. That's where I have to push back a bit. If we're translating messy human intent into crisp code and we have to make compromises, aren't we just sacrificing the ethical gray area? You know, the very space where we usually find justice, context, nuance. Are we sacrificing that just for machine speed and predictability?
That is the absolute core conflict. And the sources essentially argue that, yes, we might have to accept some level of that sacrifice if we actually want functional autonomy. Otherwise, the machine simply cannot operate reliably. You can see this tension perfectly in that traffic rules analogy the European Commission brought up.
Right.
Autonomous systems literally cannot accurately follow rules created for humans because those rules implicitly assume human flaws, human judgment, human discretion.
Like a human driver deciding to slightly exceed the speed limit to merge safely or avoid an accident. That needs judgment.
Exactly. But if an AI is hard-coded to strictly obey the letter of the law, and the human law sometimes requires judgment or even technically rule-breaking in an emergency, the AI faces this debilitating dilemma. It can't compute.
So what are the options?
Well, the EC report actually laid out 3 basic policy choices for regulators dealing with this structural incompatibility. Option A, change the human traffic rules specifically for the AI.
Okay.
Option B, explicitly permit the AI to break certain human rules, but only under very specific predefined context, like emergency maneuver.
Right.
Or option C, require the AI in those situations to just cede control back to a human, specifically so the human can disobey the rule if needed.
Wow. The very fact that we have to have this conversation proves the massive legal strain, doesn't it? Trying to retrofit algorithmic logic into a fundamentally human context.
It really does.
Okay, so if we accept that AI needs its own legal sandbox, the DOC, how do you actually implement that within a company, practically speaking?
Yeah, how do you manage two distinct operational realities side by side without them just constantly conflicting?
Right. Is there any precedent for that? Like in the human world, for one legal agreement effectively existing in two different operating realities?
Actually, yes. And this leads us to a really fantastic analogy drawn from the sources. Bilingual contracts. Torbert wrote about this back in 2004.
Bilingual contracts, how does that work?
Think of a major joint venture agreement in China. Legally, for the Chinese authorities, the contract has to be approved and written in Chinese. That's the official version for that context.
Okay.
But for the international partners who operate under different legal assumptions and language, there's usually a parallel English text. It's fundamentally one agreement governing one business objective.
But with two parallel texts.
Exactly. Two parallel legal texts defining its operational context for two different legal and, you could say, cultural worldviews.
Ah, okay. That clicks immediately when you apply it to corporate governance. So in these mixed boards where you have human directors sitting alongside autonomous AI directors.
The DOC approach suggests that internal corporate policies could actually exist in two versions. Is that right?
That's the proposal. Version 1 for humans, regulating issues based on, human thinking, social norms, personal liability judgments.
In version 2.
Version 2 for the autonomous systems, regulating issues based entirely on operational metrics, data feeds, formal protocols, things the AI can actually access and process.
So this dual system allows that core governance principle, the fair treatment of all shareholders, which the OECD emphasized in 2023, it allows that to be formalized for the machine.
Precisely. Because the AI director can't gauge fairness the way a human director might try to. It has to operate based on clear, formalized, machine-readable principles derived from that concept.
Okay, so what are those formalized principles then? How do you define fairness for an algorithm?
Well, the key ones mentioned include informed consent, non-discrimination. Lynn wrote about this in 2016, and ensuring a fair statistical distribution of risks.
So translating abstract principles into quantifiable metrics. Exactly. For instance, non-discrimination for an AI isn't about intent. It's about verifying that its decisions, based on its allowed input metrics, result in a statistically fair outcome across all the groups it affects. You measure the output.
And the informed consent piece sounds vital, especially for, you, the shareholder or stakeholder.
Absolutely critical. By creating explicit corporate policies that clearly describe how the autonomous AI system operates within its DOC, what metrics it uses, what its boundaries are, its rules. Shareholders and stakeholders can actually give truly informed consent. They're no longer stuck in that opaque agree or leave trap that the EC warned about in 2020, which often plagues black box algorithms.
You actually know the robot's rule set before you invest or sign on.
You know the rules the game is playing.
Okay, this brings us, I think, to the final, really central question for everyone involved, regulators, investors, developers.
Yeah, the big picture choice.
Should these advanced AI systems function in the exact same operational context as people? Or must we create special, dedicated, maybe even restrictive conditions just for them?
It really represents a fundamental fork in the road for how we integrate this technology.
Is the autonomous corporate system meant to be like a car? Used on general shared infrastructure or existing legal and corporate roads where it constantly has to navigate messy human chaos? Or is it more like a train or plane or even a rocket, something that absolutely requires highly specialized, dedicated, and contained infrastructure to function optimally and safely?
And the sources we looked at argue pretty forcefully for the latter, the train plane model.
Why? Based on what?
Well, if you look at the safety data, the answer seems pretty clear. Savage's analysis from 2013 showed that air and rail transport are several times safer than driving your car on public roads.
Despite their incredible power and speed.
Exactly. And the reason, primarily, the dedicated infrastructure. Airports, designated air corridors, railroad tracks.
They're contained.
They're contained, they're highly regulated, and they're optimized for machine-like speed and predictability.
So the argument is basically that trying to retrofit AI into our messy, subjective, human legal highways is just inherently unsafe and inefficient.
Right. It limits the AI's potential speed and forces it to constantly second-guess unpredictable human variables.
But is it even feasible? Creating entire dedicated corporate sectors or digital corridors just for AI? That sounds like, I don't know, building a secondary internet or something.
That's a valid concern, the scale of it.
Mm,
But the core principle, dedicated infrastructure for high-speed, high-risk machine operation, is already applied successfully in some very high-stakes domains.
like where?
Think about algorithmic and high-frequency trading, HFT, in finance.
Okay.
There, you already have specialized rules, specialized networks, co-located servers, specialized hardware, all created precisely to manage the speed and risk of machine execution and, importantly, keeping that intense machine interaction somewhat separate from generalized human trading systems.
So we're already doing it, just maybe not calling it that.
In principle, yes. The only difference here is potentially scaling that infrastructure choice up to broader corporate governance.
So the contrast becomes really clear then. You have an AI operating without a dedicated context, like, remember robot Sophia?
The citizen robot.
Yeah, who serves more as a philosophical ambassador, operating in the general human public sphere, slowly, reactively, mostly symbolically.
Versus, say, a theoretical corporate android managing billions in assets. The sources strongly suggest that kind of AI fundamentally requires the DOC, requires that dedicated infrastructure to function reliably, predictably, and at the necessary speed within a structured environment.
The difference between a goodwill ambassador and a reliable, high-stakes corporate director is that operational risk tolerance.
Exactly. We're essentially opting for rails over the open highway for these powerful systems. Hashtag tag outro.
Wow. Okay, so this deep dive has really shown us that the rapid evolution of these autonomous AI systems, especially the ones starting to wield real economic and corporate power, well, it demands far more than just tweaking existing human laws.
Much more.
Their unique technical structure, their operational speed, it seems, they require specialized legal and operational rails, this dedicated operational context. We're essentially talking about building a separate, tailored set of rules where machine logic can safely govern.
And that leads us maybe to a final provocative thought for you to chew on.
Okay.
Given the documented safety gains, the performance improvements we've achieved through dedicated infrastructure in high-speed, high-risk transportation trains, planes, should we maybe stop trying so hard to retrofit powerful AI into human society's existing messy contexts altogether?
Stop trying to make them fit our world.
Perhaps. Instead, should our focus be maybe 100% on building optimized contained environments, these digital corridors, dedicated regulatory spheres, closed HFT-like markets where the AI's full power and speed can be safely realized and meticulously monitored without the constant threat of unpredictable human legal friction?
So are we saying true autonomy requires us to just concede separate operational turf entirely?
It certainly forces us to ask that question. Do we build them their own world to operate in, or keep trying to make them navigate ours? That seems to be the fundamental choice ahead.